this breakout session it's called a workshop, and so I was juggling trying to figure out how much we can do, how much interactive things. So I'm hoping you have a web browser and that you'll play along on things. So, but I'm Chris. I'm a computer scientist. I'm in Harrisonburg, Virginia, um, and I like the physical world as much as the virtual world, and so I look for ways to try to bridge the virtual and the physical together. So John did an excellent job of illustrating that in the keynote. So thank you, John. Um, my dad had every imaginable tool in his shop. He had his own, we had our acreage, and he had his own little shop there. And um, but every time I tried to make something, something didn't feel right. I really liked the brain tools. I liked math, and I liked code because I felt like mistakes were cheap. I didn't have to burn through a board or bend a nail, and so brain tools like math and code they were more learnable. They were more tinkerable. They had an explicit notation. Like I could look at other people's creations and see that, oh, that's how they did that. Uh, and they were forgiving. I could edit things. They took time, but they didn't take up money, which was important. So now, as an adult, as a professor of computer science, I continue to try to unify the physical and the virtual worlds. And so one of those ways is through a platform I've been working on called Twoville, and it's a programming language. It's a development environment for making real objects. And so I've got a few things. Um, the cheapest thing we can possibly make are these little vinyl stickers. We'll write code to just create stickers. I used to do 3D printing. I would go into classrooms and bring my 3D printer with, and maybe one person would get a model by the end of our time, and they'd fight over the support material and all that. So I kind of switched to two-dimensional stuff, vinyl cutters. You can make little greeting cards. Here's a little mosaic cut out. We put backing paper behind here, but it's all cut with code. Uh, you've probably heard of origami, which is folding paper, but there's also kirigami. Kiri is the Japanese word for cut, and so I can make greeting cards that have pop-ups inside them. Um, this is a shape that we'll make together here in a second. I don't know if it's a capybara or a camel or a horse, but this is embroidered. So we coded the design, and then we used an embroidery machine that accepts SVG files. And so uh, uh, got nice laser cut materials. This is written using just a little bit of recursion. Um, nice little system here, but it's all laser cut. And uh, we let's see, my kids have made their own clothing. So this is faded at this point, but there's a little bird there that was made out of just simple polygons and stretch shapes. But we used heat transfer vinyl and just applied it to a t-shirts. Actually, this one was we've switched over to using fabric paint inside of a stencil lately because it works a little bit better and holds up a little bit better. But this is what my son made this one. He calls it a wiggly wurf. Um, I don't know, but so we're going to see these are all made in Twoville, which I'll share with you here. I've kind of been working on this project, sort of, it's a passion project for about 6 years. I started with a student who came to me saying, "Hey, I want to do some project with programming languages." That's a class I teach. And so we started working on this, and we've probably used it with about 500 middle schoolers and high schoolers at this point, in summer camps, uh, hour-long visits to our campus and so on. But uh, but all these things that we can make, they're born on the computer, but they don't die there. We start with the digital design, but it's something we can wear and carry and give, and so so I'll share my goal today is to share Twoville with you, give you a chance to play around with it. It's free, it's on the web, it doesn't have accounts at all, so there's hopefully no encumbrance with getting it approved by IT. So, but yeah, but the core mechanic is code, but you'll see that there's ways to do design work that it's not entirely code because sometimes just writing code is a little indirect. So, all right, so I'm gonna share a link with you of the notes that I've got, just like John did. I have a collection of notes, and you're welcome to follow along there. So my website is 2d.org, and then Fab Educators Summit 2026. All right, and I will share my screen. So, all right, forgot my opening slide. So there's me. I'm Chris Johnson at James Madison University. Here are some designs that folks have made with code. It's a little bear. These are all students. Little cat. Um, this little caterpillar. Little kawaii cloud. Nice little just monster of some sort. This one took a lot of time. Student worked on this the entire time. I didn't think he was going to get a sticker by the end, but he pulled through. There's a little scarecrow made out of we call these Franken shapes, just composite shapes made out of circles and rectangles. Here's a pregnant woman. That was the student's name for it. This is a woman's self-portrait that she made. And here, these are some mosaic greeting cards that we used in a summer camp for refugee students. There's a little turtle mosaic. And so, okay, so now we're going to start writing our own. The language is a little bit, it's a lot like Python. Currently, it's text only. In the past, I've played around with moving between text and blocks, and right now we're text only. But we're going to make just I'll start with two shapes, and then I'm going to give you an exercise that you can combine these things. But here's how you'd make a circle. And one strategy I've sort of taken that's different than a lot of languages is that in a lot of languages you have a circle function, and you would put some like an XY coordinate and a radius, and you might say something like 20, 30, 15 right there. It's hard to understand exactly what's happening in this code unless you already know about the circle function. And so I have a slightly different syntax for various reasons, but we spell everything out, so we have named parameters. But so we're going to have a center point at say 10, 5. So X and Y coordinates, and then we'll have a radius of say 5. Okay. If I hit run, there's my circle right there. The other thing I try to do is the folks that are using this are often on small screens, and so I don't want code to get very wide. So I'd rather it be tall and have just one direction of flow. And so that's another reason for not packing in a bunch of parameters onto one line. But so here's where things get a little crazy. I've written the code, and if I wanted to say make the circle bigger, well, normally I would have to go and figure out, okay, I'll try 6, something like that. I'll try 7. But I wanted to be able to have this be a little more visceral. And so there's a technique in programming languages and HCI called bidirectional editing. And so I can actually grab these handles. Once I put the cursor here, the handles appear, and I can drag. So if I hold down the Shift key, it'll lock it to integers, snap it to the grid. But and then I can do the same with the radius. I can grab that. So I think this is fun because I can use my math side of my brain, but I could also use the artistic side of my brain to try to feel, does that feel right? So that's a circle. A rectangle is fairly similar. Also, this might be a contentious choice, but the indentation here matters. These properties belong to the circle, and so you have to push them in. Some languages have curly braces and so on to show how things belong. I've chosen to use just indentation, just like Python. Let me see. There's something in chat. All right, there we go. And here we go. So we'll go to rectangles, and this one has a corner. You can either do a corner or a center, depending on how you want to shape it. So let's just do 5 and 6 and size. Nope, I renamed this actually. So there's a width property. Let's set it to 15 and a height property. Let's set it to 7. So there's my rectangle. And I get 3 handles for this one because I have 3 properties. I can do the exact same thing. All right. And if I want to modify the color, Sometimes when we're building these sort of Franken shapes, I encourage students to just stick with black and white. So Danielle asks, how do you get the handles again? I Just to avoid sort of flurry of information, you actually have to click the cursor inside the shape. I want the code to be the navigator. I don't want the users to forget what's going on in the code by just using the drawing interface. And so if you click the cursor in there, and then the handles show up. There's other things that happen if I say change the radius here, but I haven't rerun the program. The handles are gray. That's because they're no longer in sync with each other. And so if you just hit run again, um, we get the handles back. Does that answer your question, Danielle? Okay, great. All right, so are you ready to try this out on your own? If I give you an exercise? Okay, here we go. So if you go down in the notes, if you've gone to that link, uh, so here we are. Oops. So if you're in the notes that I sent a link to, there is an image of this little creature. I put it somewhere, the little card here. Here it is. So this little creature, the strategy that we've taken in all our workshops is we get students drawing on paper first. So they draw, they get a visceral feel for things. So that's stage one, draw. Stage two is they measure. So they put numbers on things, they measure the distances, they find the XY coordinates. And then step three, stage three is they actually code. Um, I feel like that's worked a lot better for us because that makes coding almost like a translation step. They've done the design work ahead of time, and then coding is not everything all at once. So my challenge for you in this workshop is to go create this little creature. Um, we don't have time for you to draw, sorry. So I pre-drew for you, but go ahead and see if you can make this creature with those rectangles and circle commands. And if there are any questions, I'm happy to support you in it. I have a little example of rectangles and circles in the box right below. I'd welcome if people want to have a conversation while you tinker. Happy to answer questions.
I'm curious about the choice to make free dragging not default snap to integers versus having to hit a key to snap to integers.
So uh, I don't have a preference one way or another. Like I think that sounds nice because I find myself using it almost all the time. Um, I just I'm hesitant to pretend I know what people would want.
Yeah,
What
valid.
have you used systems where that is the default?
Uh, I mean, I feel like snapping to a grid is often the default, and especially with kids, I feel like they're gonna want things to line up more than they're gonna want infinite scalability.
Mhm. My only hesitation is that it would make things disappear more quickly. Uh,
Mm,
if their numbers are
that's true.
small, and so the continuity of having real numbers there,
Hmm.
I don't know. But I think that sounds like a nice option though. Like just automatically saying what the preference
Yeah.
is and have shift switch to the opposite one.
Or like I'm just thinking of Tinkercad. I think you can set the like snap grid to be like point 0.1, point 0.01, point 0.001.
Yeah. If let me go back to my. So here's me and my big screen again too. So on the right side, I have this panel here. Um, and so this is also Tinkercad, you know, they have a full team. That's their job. My job is to teach computer science, and so all this is probably a little bit rough here, but the fraction digits here, I can set that to higher numbers. So if I want more digits of precision after the decimal, I can do that. So it is possible. If I drop that number down to 0, it'll do that snapping.
Oh, perfect. So you already have it.
Yeah, it's just not the default. So yeah.
Yeah. No, but I think not having that be the default is the right choice because you want to expose the capability.
Mhm. Okay.
Chris, how important have you found that the students actually make the physical object versus just doing the software?
Uh, I mean, I haven't systematically looked at
Yeah.
that. When I see people proud of their work, I mean, it's away from the screen. Um, one of the things that one of the primary ways we've been using it is in a summer camp for refugee kids. Harrisonburg is a part of the refugee resettlement program. Uh, and so we'll get students who love to make like shirts that have their country's flag on it or something like that. And so I think that pride in connecting back to their home country and having something durable, tangible. I don't think they care about the digital part of it. Uh, but I also prime them to think that way, so I don't know. Uh, Anybody have the capybara shaping up?
Is there a way to change the color of the object?
Yeah, okay. So here I am on my screen again. Um, there is a color property, and there's various built-in colors, or you can use an RGB triplet, um, red, green, and blue triplet. So if I wanted a red rectangle, there's a bunch of built-in constants. The constants are preceded by the colon symbol. So if I hit run, I now have a red rectangle. And one of the things that's built into Twoville is that if you just use black and white and you draw things in the order you want them to sort of stack together, there's a command that we'll see here in a moment that will make a union of all the black shapes, and it'll make a whole out of all the white shapes. Because we don't want to cut, we don't want to send this to the vinyl cutter. Because that would have internal cuts. Is anyone willing to share their capybara code and I'll make a sticker out of it?
I don't have an eye yet, but sure.
Sounds good.
You want me to just paste it in the chat?
Yeah, if you're willing. All right. So I'm copying Nick's code over here and pasting. All right. And then, you mind if I make this the rectangle
Yeah, yeah, go for it.
integer okay? There we go. And then, this is something that I found is useful too. This is a secret. I'm going to just go ahead and copy this little ear circle. I'm going to paste one right below it. I'll put an eye in there for you, Nick. So if I run this right now, I have two black circles right next to each other. I'm going to move this one down and just do a color equals white. And that looks a little bit big. Kind of looks, yeah, I'll use the handle here for it. But all right. And so at this point, so if I were to export this right now, I would actually have 5 or 6 different shapes all together. There is a special command I can include here. Let's go to the very bottom. And it's called the mat variable. So let's see, too many Zoom windows are covering up my screen. So we'll do silhouette. So colon silhouette is the option. There's a couple different options, but so if I hit run, and over here in the settings panel, there's an export SVG. So I'll hit export. I'll call this capybara. And then I'm going to go to, what I have in my possession are, for vinyl cutters, I have Silhouette brand cameos. But the same thing would work with Cricut or whatever other cutting tool. So here I am in Silhouette Studio. I'm just going to open that up. You can see I got my taxes, W-2. Let's see, we called it capybara. And it's really big at the moment, so it all depends on the coordinate system we have, but there it is. Have some things in place to make it scale a little bit better, so it's not quite so painful. But so there it is. There it is. If we click on side of it, we click inside of it. I can see the control points there. It seems to be all one piece instead of separate shapes. So that's what that mat command or that silhouette command did. So if I now hit send, I'll find my cameo here. I have to keep moving windows around. All right, switch to vinyl glossy. And maybe we might have to skip this step. Not sure what's up. Let me try plugging in. I'm plugging in through an adapter, so let's see if that helps. Okay, that sounded good. And it says ready, so I will go ahead and cut. Let's see. Use see my cameo. Oh, sharing for a moment. Okay, sorry, wasn't fast enough. Okay. So there I have a very large capybara. Oh, we'll cut it out. But this is what has made me vastly prefer vinyl cutting over 3D printing. So here I'll go ahead and peel. And Nick, that's what you made. So
Fantastic.
yeah. All right. So someone asked in the chat, what part did students struggle with the most? It largely depends on the audience. I say I like to start with drawing, and that has advantages and disadvantages. But when you start with drawing, they don't quite know the limits of the system yet, and so they'll draw things that don't follow the grid lines. And I want them to not have to follow the grid lines, but then it's not a great fit for the coding part of it. And so I'm constantly trying to figure out how much do I support, aesthetics, and how much do I support the structure of math and code. So Danielle asks, have you tried laser cutting yet? So yeah, I showed this thing earlier. That's laser cut. You can't tell really from the video, but there's acrylic in there and there's wood. So I sort of made 3 different tracks. Actually, what I did is, this was a birthday gift for one of my kids. I wanted the layers, and I put a bunch of really small ball bearings inside, and then you can just roll them around. Um, but these are the outer pieces, the leftover pieces. This is a Penrose triangle made out of acrylic. So that was coated up in Twoville as well. Actually, one of my favorite things about this is that I think thinking parametrically is wonderful. Just being able to come up with a design and then write it in terms of variables that you can change. And so I actually have a program that lets you pick n, which is the number of sides to a Penrose shape. So you can make a Penrose square and a Penrose pentagon and a Penrose hexagon and so on. Because it's just a very deeper, much deeper level of thinking to be able to express it abstractly like that. Yeah. So I'm going to go to the next little demo, and I should too say we started at 12:40, right? Then we end at 1:25. Is that right, Nick?
That's correct. Yep.
Oh, okay. All right. So let's do another little design here. So rectangles and circles, they're nice. You can put them together, but eventually you want to get to a more advanced concept. So I'm going to make a little polygon here. We're gonna try to model a nut, a hexagonal nut. So let me get my notes back up just so I don't go too far afield. But I'm going to also introduce some variables. So it's code, so we can have variables. I'm going to make an inner variable. So ultimately, I'm going to have an outer radius for for the nut and an inner radius. And so let's just say the inner radius is 8.
Share your screen, Chris.
Oh, thank you, thank you. This happens a lot. Share my screen. Okay, thank you. All right, so I have an inner variable and I have an outer variable. And let's just make it maybe, I don't know, 12 more. Okay. So I'm gonna write this one way it seems so very verbose, and then we'll find a way to not have it be so verbose. But there's another command called polygon, and I'm gonna indent inside of it just like I did with rectangle and circle. And we want to establish a bunch of vertices. So I'm gonna do a vertex, and the syntax here is gonna take a little bit of getting used to. There's various reasons that the syntax is what it is, but I'm gonna do vertex and say what its position is. And I'm going to sort of walk around a circle. I'm going to go start on the far right, and then we'll go 60 degrees around, and 120 degrees, 180, 240, and 300. So instead of using XY coordinates, I'm going to use polar coordinates. So here's our radius. I'll start with outer, and we'll go 0 degrees. But to convert it from polar coordinates to Cartesian coordinates, I'm going to do a little function call. I'm going to convert them to XY coordinates. And I'm going to steal this line and change my next one to 60 degrees. And the next one to 120 degrees. And just to make sure that things are going on the right track, I'm going to hit run. And I see the one corner of my hexagonal nut right there. I'll keep going around. Oops. So there's the top half. And bottom half. And there we go. So there's my hexagonal shape. But if you've been around code before, you see that, well, this is very formulaic. There's an algorithm here. It'd be nice to not have to say this thing 6 times, but have a loop instead. And so I'm going to replace all this just to say it one time. I'm going to get rid of those, and we're going to add a little for loop right in here for degrees in, or we can do, if we want to start at 0, we don't have to say in. We can just going to say up to 360, and we're going to jump by 60 every time. And then instead of my 0 here, I'm going to put degrees. maybe for the interest of fitting it on the screen, I'll just say D. Okay, so if I run that, I should get the exact same shape, and I do. Often when we're doing sort of modeling in design work, we'd like to add rounded corners here. So there's another command I can call before I start drawing these vertices. I can make a fillet, and I can say how big I want it to be. So maybe it's 2 units. So if I run that, now I get the nice little rounded corner, and I even have a little handle for that. So if I click on the fillet, I could drag to affect how rounded it is. Okay. And then so that's a pretty good start to the nut. Let's put a circle inside so that we can subtract out the threading. So I'm going to do a center of 0, 0 and a radius of we'll do the inner right there. And then its color will be white. So if I hit run, I should see nice little shape there. So if I were to cut this out and do the matte silhouette, I'd get a nice shape there. What's kind of interesting, I'd like to set students up for seeing that, hey, we've got this thing made, but if we start to tweak it a little bit, it's a problem. So if I click in my circle here and I drag on the radius handle, we see that there's an issue. So here I am dragging it, and what's happening? Well, I'm losing the integrity, the strength of my nut. It's when I'm dragging on the handle, it's trying to preserve the inner variable. Like that's an important variable apparently. So it's actually going back and modifying this right here. And that changes outer, and that changes the hexagon. So, but the effect is, what's happening is that the ratio between the inner and outer it's getting closer and closer to 1, and my hexagon's getting weak. So we can fix this. We can try to express this differently. Maybe instead of doing an addition, maybe we should have a multiplicative. We should have a ratio here. So the original setup I had was like this. So the inner was 8 and the outer was 20. So if I wanted to maintain that relationship, that when inner is 8, outer is 20, well, let's see if I can express that without addition, but multiplication instead. Well, how do we get from 8 to 20 with multiplication? We multiply by 2.5. If I do it that way now, and if I drag inner, that works much better. And if I could go a little farther and also express the fillet as a parameterization of inner too. So, all right. So that's our second shape using the polygon command. Are there questions on that? Somebody's got a chat message here. Is a time variable possibility in order to see an animation? So this is Dennis is asking this. I've been working on this with a student, and there is. I'm afraid to try it, but we'll do it. Okay. So the syntax is a little bit different here as well. So there's let's do a rotate command. And so rotate, we establish a pivot. Let's just pivot about the center point, and let's have a number of degrees. Let's try 45 just to test this out. So if I run this right now, you see the nut just rotated a little bit. One of the things we can do is we can sort of set up this timeline syntax. This is something that the student and I have been experimenting with. I don't know if it's good or not, but this is what we've come up with. So we're trying to make it look a little bit like mathematical limits. So when the time is 0, the degrees is 45. Or let's go with 0. So it starts off unrotated, but as we approach, say, time 100, the degrees is 360. So that's the reason we're doing it this way is to make that handle dragging work a little bit better. It's not just a function call to show the two endpoints, but um, so it's run. I'm going to bring up the timeline, show the time scrubber right here in the settings. And if I go ahead and hit play now, the outline doesn't currently rotate with it. That we haven't gotten that working yet. But so Dennis, does that answer your question?
That's great. I just like the one more extra, one more variation there to play with.
Yeah. So this is definitely something we've been experimenting with. So we've also tried to figure out how can we still fabricate it when we've got time in there, and we've come up with some just borrowing ideas from artists and so on about how to do that. The Scanimation books to do these fence post animation things too. All right, and then I think so. It's 1:15. I'm gonna go ahead and do the last little exercise. So Bezier curves, I think, are fascinating. So in case you're not familiar with those, I'm gonna do a quick drawing. So let's see, I lost my tablet here. We've all used Bezier curves, probably in a drawing program, and not quite known how they worked. They're sort of magic, but the way, let's see if I can. Okay. So the way I present it to students is that, well, we know how to make a line segment. We've got two vertices, and we want to put a line between them, but sometimes we want to make this a curve instead of a straight line. And so what we want to do is we want to put a black hole into the scene. So we put a black hole right there, and that sort of sucks the line toward it. It doesn't quite pull it in completely, but that's our goal. And so I'm going to show a little shape here that uses Bezier curves. And we'll see one other drawing command too. So I'm going to erase the polygon here, and I'm going to stop the animation. So I'm going to use another command. This is the most expressive one, the most flexible one. It's just a plain old figure. You can draw strokes and so on with it, but they don't have to be closed shapes. We're going to give it a stroke. Give it stroke a weight of 1. You can set the stroke's color as well. But, and then there's a few commands here to start like putting the pen down and drawing on it. So I'm going to start off at say 16:0. So this will be on the far right. I'm trying to make a diamond like on a playing card. And we're going to start off with just making one quadrant of that diamond. So if I hit run right now, here's my first point. I can click through and see if I put the cursor down, I can sort of trace through how it's behaving. So there's my go position. Here's my line position. I can drag these handles around just like the other handles. But what I want is, sometimes those playing cards have a little bit of flair to them. They don't have just a straight line. And so I want to put a black hole, say right here, and have the line get sort of sucked into it. So I'm going to switch this line to a quadratic. So there's a couple different kinds of Bezier curves. If you have one control point, one black hole, that's a quadratic. You can model it with a x squared equation. If you have two black holes, that's a cubic. And so we're just going to go with one black hole. But in addition to position, when I only have one property, I can use the dot syntax. But if I have multiple properties, I should use this, break it down into separate lines. I'm going to set a control point right here. And I kind of want it to be around here, somewhere over here to suck the line inward, make a little bit concave. I can see my coordinates on the top right. I can also hit Alt click or Option click, and I get that coordinate dropped into the source code. All right, and now if I run it, and if I click right here, I can see here's my black hole right there, and I can drag it inward. So that's one quadrant. I want a full diamond pattern, so I want the next quadrant, and I want the other two quadrants. It'd be nice if I didn't have four separate quadrants to fiddle with. I want symmetry, and so there's a mirror command. Um, Add in a mirror, and let's have it. We need two properties for a mirror. We need to know what's a point about which we're mirroring. So I'm going to do a pivot. We're just going to go around the origin, and then I need an axis that goes from that point. So let's do a vertical axis first. I hit run. There's my flip that direction, and then really the other half is another mirror, so I don't have to uh, do any extra work here except add another pivot of 0, 0, and now I want to pivot over the x-axis.
5 minute warning, Chris.
Okay, great. So this is good timing. So this is my diamond. It's sealed now. If I want to put a color on the inside, there's my diamond, and I can continue to drag it until I get it right the way I want it to be. Yeah. So I will go back to my slides here. Just so that sort of that wraps up the what I have to share. So it's Twoville. It's been my vehicle for, I don't know, playing with geometry, for getting out to schools in my community. Um, I it's my way of uniting that physical and virtual worlds, that we experience and move back and forth between. Twoville's available for free. It's definitely got bugs, but I'm also available to fix them. I'm always making gifts with it, and so if you find yourself wanting to use it, I'm happy to support you in that. Um, if I go to the panel up here, there, so you can save models, and they save with the browser. I don't have a separate account system currently. I know that some schools are limited by that, and so I've kind of just kicked it down the road to think about that. But if I were to save this question mark, um, I can come back to it later as long as I have the same browser. The Learn tab has a number of, ooh, looks like I broke that. So I will fix that before the day is over, but there are a whole suite of tutorials that should be there right now, but I've messed something up. So I will stop sharing, and here we go.
I like the send to Chris button.
Oh yeah, so I use that in the workshops because it just expedites me pulling down their code to the Silhouette Studio. But that's my way of combining fabrication and math and computing, and being able to get out in my community. So
Chris, I really like the way this parameters kind of come to life and you get to play with. Have you thought about having it where I might have a traditional drawing tool, like being able to just pull in a rectangle off of a, simple vector drawing and then see it and then get to play with because I love the mathiness that I get to encounter, but the coding part, is second into to getting to play with the parameters.
yeah, so because I'm a computer science educator, I've started with code, like that's my
Yeah.
And then I don't know if you've seen Cuddle,
Yeah.
the Cuddle tool, and so I feel like Cuddle does that really well.
Okay.
So I'm going to let them do it well. But I would love, yeah, to have a system that lets you like establish constraints instead of having to write code. I've often dreamed about like a more natural interface for that kind of thing, but I haven't
Yeah.
come up